this past week in a nutshell, part 2. I had an interruption there, so yeah. Okay, so so we were going over trigonometric ratios, right? And now we're on tangent. So the tangent of A would be BC over AB. Okay, so easy. I think the word's mnemonic. Easy mnemonic to remember this is so katoa. So there you go, so katoa, which means sine is hypotenuse, is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So katoa. I think that's pretty easy to remember. Okay. This is Wednesday. Now, Wednesday was a bit more confusing. So, hold on, just real fast. Okay, back to business. Okay. So we were doing trigonometric ratios on the calculator. This was, I think it's the next lesson. Okay, let's go over how to do this. Okay, so you have, let's draw a diagram. So say this is your triangle thing, and this is A. This is 20 degrees. So you want to find the sine of angle A, which is 20 degrees. The question would be sine 20 degrees. And then here we go. So, my calculator, don't know about yours, just put sine button, and then sometimes their parentheses would come up, you put 20, and then there's like shift, and then this weird button down there, D or G, and then number 1, and then you press the equal sign, and that's the answer. And you want to round, most likely you would have to say sin 20 is like 0.3. Sometimes you round it to the tenths, sometimes you round it to the hundredths, sometimes you round it to 4 decimal places. It's weird. Okay, the next thing we learned was kind of weird. And then the rest is pretty simple, right? Like, there's cosine and there's a tangent button on your calculator. It's pretty much the same. Next part was trying to find a missing side length of a triangle, of a right triangle, using trigonometric ratios. So this is ABC. And then, angle A is 20 degrees. We'll just stick with that. And you're looking for angle X, not angle, side length of AC, which is X, 18. Okay, so if you're given angle A, and then you're given this side length, and then the hypotenuse, what trigonometric ratio would you use? I'm gonna give you some time to think about that. You got it? Okay, well, that would be cosine. So you would do the cosine of 20 degrees. And since cosine is adjacent over hypotenuse, you would do 18 over x. Now, this is weird. You gotta isolate that x. So, you would multiply this by x over cosine 20, and both sides by x over cosine 20, to get x is equal to 18 over cosine 20. And here we have the calculator. So, what's that? So since x is equal to 18 over cosine 20, that'll be 18 divided by cosine 20, which is equal to about 19.2. So the length, so x would be about 19.2. Now let's do another one of those. So say this is like 27. So, and what would you do to find x if you had to use 27? I'm gonna give you some time to think about that. Okay, what did you get? Because that's sine, and you should have got sine. And if you didn't get that, you should probably look back at the other video, part 1. Okay, so that means it would be sine 20, right? So sine 20 equals to opposite over hypotenuse, which would be 20. I didn't do that right. Oh well. 27. No, that's right. It's just I didn't get what I was thinking. Never mind. Okay. So same thing. X over sine 20 equals x over sine 20. So you get x equals 27 over sine 20. Boom. Use calculator. 27 divided by sine 20. You get 79. About 79. Okay, let's do a different triangle. A, B, C. So we're going to do angle A is 45. 45 degrees. No. Too easy. 46. I screwed up the system. So you're looking for this adjacent. It's x. This is 14, let's say. Okay. So you're looking for x. What would you do? Let me give you some time to think about that. Tangent. Yeah, that's what you would do. It's cringy. So tan 46. Never mind, let's switch these. This was 14 now, and this is x. So x over 14. So you just multiply both sides for 14. And then in your calculator, get rid of that. You 14 times tan 46. Look, there you go. 14. X is about 14.5. Yay. Okay, let's move on to today's lesson. Thursday. Today's lesson was just verbal. There's nothing you can do in this swimming board. I am sorry. But what you can do is draw yourself a triangle. Right? A right triangle. But like actually do this with a protractor or a compass. So, and then you would, so today's lesson was about finding the angle measures, right? There, finding angle measures. So, in actuality, this would be an actual right triangle, and then you would measure out everything like centimeters or whatever. And this would be just have like don't measure these. Don't measure those side lengths. Just find, and then say like this is a triangle. Round to the nearest tenth of a centimeter. We're gonna go back to this your triangle later doesn't have to be this triangle. So, you have this triangle, right? We're going to use trigonometric ratios to find out these acute angle measures. These acute angles measures. Okay, there's actually some notes for this. So copy this triangle. The title of the thingy is Calculating Angle Measures from Trig Ratios. That's the title of today's lesson. So, like this one, you can calculate one of the two acute angle measures. And like the ways you can find out from there, this top triangle is the triangle sum theorem. Making this super small. You don't have to make it this small. But that's not what we're doing today. We're using trigonometric ratios. It's horrible video quality. I'm sorry. So, okay, I'm just copying all the notes here. Solving, right? Oh, shoot, I'm out of space. Triangles means finding all angle measures and side lengths. You can just write this full out like I did over here in my notebook. And then we wrote today, focus on the angle measures. Sorry, I'm left-handed and I suck at writing. So there we go. So, we're going to be asking, quotation marks, in calculators to provide an angle measure from trig ratios. I kind of give you some time to look at that. You can pause it if you feel like. This is stuff. Okay, moving back. Flip. So you would use inverse trig ratios. Those are they're gonna look like this on your calculator. So this is the inverse of cosine 1, which is it looks like co to the negative 1. Sine and inverse is sine, and the inverse a tangent. That's what they're gonna look like. This one is too big. It's not times negative 1. Okay. And then the next note is like if we have like a sine ratio, you would use inverse of sine. That makes sense, right? Okay, so you would either use the shift button on your calculator or the second button. And then you press sine, the sine button, because right above, if you look at my calculator, there's the sine button, and then right above that is the inverse of sine. And then you would put sine negative 1, and then you would put so Miss Fuji gave us this number, so sine, so it's shift sine 0.43. So you do that. Sometimes, if you have a different calculator, you put it in front. Sometimes you have to put it in parentheses. It's weird. I'll give you some time to figure that out. You can pause it. Okay, that's 48. And you want to always round to the nearest degree. No decimals. 40. That's about 48 degrees. And then you do the same thing again. Shift, or like the second button for the cosine. And this is the other example that this Fuji gave us. 9336. And then it's basically the same, so I'll let you figure it out. I mean, you just look above, you just shift and cosine button because it's right above. Give you some time to figure that out. You can pause if you feel like it. Okay, that's going to be about 21 degrees. And then shift or second, and then you can do tangent. And then she gave us 2.355. I'll give you some time to figure that out. You can pause if you feel like. I said that a lot. Okay, this is about 67 degrees. Okay, this is the example she gave us in class. This is a triangle. This is 4 degrees. It's 3 degrees. It's 5 degrees. A, and this is B. Copy down that triangle in your composition notebook. And then for angle A, and the cosine of angle A. The cosine of angle A, so if this is the adjacent and this is the hypotenuse, would equal 4 over 5. But since we're looking for the angle measure of A, we're gonna rewrite this equation. We're gonna change this equation to the measure of angle A equals the inverse of cosine 1. The inverse of cosine 1 of the inverse cosine of 4 over 5. That's how you say it. Inverse cosine of 4 over 5. Wow, this video is long. And then let you figure that out. Yeah, okay, so that's about 37 degrees. Okay, let's move on to the next one. We're looking for the sine of angle A. So I'm going to let you figure out what the sine of angle A would equal to. That's 3 over 5. Good job. So the measure of... So the measure of angle A is equal to inverse sine of 3 over 5. I'll give you some time, and let you have some time to figure that out. You can pause if you feel like. Guess what? That's 37 degrees. Wait, no, it's not. Yeah, it is. It is 37 degrees. And then you do the same. You may be asking, why are we doing all this? It's because we had to do this in class, and now I'm gonna make you suffer too. Okay, so this is the tangent of A. And then, so I'll give you some time to figure out what the tangent of A equals to. Yeah, that's good. 3 over 4. I feel insane. I feel like I'm talking to myself. Well, I am. This is creepy. So the measure of angle A is equal to the inverse tangent of 3/4. Give you some time to figure it out. You probably guessed it by now. 37 degrees. About 37 degrees. Squigglies. Then angle B. The cosine of angle B. Put one too many thingies. Equals. Give you some time to figure that out. 3/5. Give you 0 time for that, but who cares? Measure of angle B equals cosine, the inverse of cosine of 3/5. To give you some time to figure that out, that is 53 degrees. You probably guessed that from this. Okay, let's move on. Sine of B. Okay, I'm going to do something because I forgot this on the Wednesday one. The cosine of B, and the cosine and the sine of A are the same. You see that? And then the cosine of A would be the same as the sine of B. Just to let you know. Because they are complementary angles. So you see, in this right triangle, there's cosine and there's sine. This cosine is equal to this sine, and this cosine is equal to that sine. Yay! Okay. Measure angle B equals the sine negative 4/5. I think you get it. So, obviously, you guessed it. It's about 53. And then tangent of B equals, it's going to be the reciprocal because they have different adjacent and opposite sides. 4/3. Now that's fun. Measure angle A equals B. I looked at something else. I'm sorry. The inverse tangent times, not times, don't use times. That's the wrong terminology. Of 4/3. And then you guessed it. I'll give you some time to figure it out anyways. Put it in your calculator. B equals 53. It's about 53 degrees. Okay, remember that triangle we did earlier? So, do some practice with that and try and find angle measures all three different ways. Both unknown acute angle measures all three different ways. Hold on. This was this past week in a nutshell. Not part 2, I guess. Have a great life.